What we know so far is that amines are basic, and that's due to the lone pair on nitrogen. But we also learn, okay, that it's not just the presence of a lone pair on nitrogen, but also that's very important is the availability of the lone pair. Electron donating groups should enhance the availability of the lone pair on nitrogen, and therefore the amine should be more basic. Now, conversely, electron withdrawing groups should reduce the availability of the lone pair on nitrogen, and therefore they should reduce the amine basicity. Let's now take aniline, aminobenzene, to discuss next. So this is aniline. The pKa of aniline is actually 4.6 roughly, 4.63 specifically. Now, if you recall, 4.6 versus about 9, 10, or 11 for alkyl amines in general, between 9 and 11. So this is significantly less. So what does this mean? Well, this means that aniline is much less basic than an alkyl amine. 4.6, the pKa, much less value than that of alkyl amines, with a range of, in general, between 9 and 11. So what does that mean? Well, this means that the lone pair on nitrogen should be much less available. So why is that so? Well, it's due to this benzene ring. So let's try to prove that by resonance. Why should aniline be much less basic than an alkyl amine? Now, if you take the lone pair, our central point of attention or focus is actually that lone pair on nitrogen. You can take that lone pair, we try to delocalize it by resonance. If we make a double bond here, then of course this carbon-carbon double bond is broken simultaneously. And if we do that, we get another resonance form. And now the lone pair is on the ring. We can continue to delocalize electrons in a similar way. And now we get another resonance form. And we can get now one more. By this resonance, it's actually clear that the lone pair on nitrogen is much less available because it's actually delocalized over the ring by resonance. So this is electron delocalization by resonance, which makes the lone pair much less available. Remember, the availability of the lone pair is extremely important. That it's not just its presence again, it's its availability. The lone pair on nitrogen in aniline is much less available than in alkyl amines. That's because that lone pair on nitrogen is delocalized by resonance over the ring. That's why the pKa is much less. It's 4.6, much less in this case in aniline than in alkyl amines, whose pKa range is between 9 and 11 in general. Now, what effects would groups on aniline have on the aniline basicity? Let's take an example of an electron donating group and an example of an electron withdrawing group. So if we take aniline, but it's substituted with an amino group. So this is the lone pair on nitrogen. This is the amino group, and of course amino groups are electron donating groups by resonance. So what we can do is we can actually take the lone pair on the nitrogen, the substituent. We treat this as the substituent. This is what we focus on or our reference point, if you like. So we take the lone pair on nitrogen, we make a double bond here, and then we try to delocalize electrons, so we get another form. So this is the resonance form, and now we can continue with the delocalization of the electrons on that nitrogen. And if we make it, if we take that lone pair, we make a double bond here, and of course this carbon-carbon double bond must be broken, releasing electrons on the carbon that's bonded to the amino group in aniline. So this is what we get. So electron release, if you like, or electron donation by resonance by the amino group, because it is an electron donating group by resonance. If you look at the lone pair on nitrogen, this is what we focus on. It's actually more available now because electrons are localized. So there's electron donation by resonance here. So there's electron donation by the EDG by resonance, which is the amino group. The lone pair here is more available, and of course it is more available compared to aniline itself. So therefore, for amino aniline or para-amino aniline should be more basic than aniline itself. That's because it is substituted with an electron donating group by resonance, which enhances the lone pair availability on nitrogen by donation of electrons. So there is electron localization here. The lone pair on nitrogen is made more available. Now, if 4-amino aniline is more basic than aniline itself, this should be reflected in its pKa value, and it is actually about 6.2 roughly, and of course it's higher than 4.6. So clearly 4-amino aniline is more basic than aniline itself. That's because it is substituted with an electron donating group by resonance. So therefore the conclusion here after this is that electron donating groups by resonance should enhance the availability of the lone pair on nitrogen, and therefore the amine or the aniline, like in this case, should be more basic than an unsubstituted aniline. Electron donating groups enhance basicity of amines.